Central angle, remember, is an angle whose vertex is the center. Okay, of a circle. Right, and so when you are looking at this, the additional kind of relationship that goes along with this is that central angle and an arc measure are exactly the same. Okay, so the measure of an arc is equal to the measure of its corresponding central angle. Okay, and so what that means is if you have an angle measured as angle A, okay, that is a central angle. So if this is the center of your circle, then the arc measure that's intercepted here, which is called M, those are equal to each other. And now the M it's not a distance or a length. Okay, the arc measure is different from an arc length. Okay, an arc measure is just, again, it corresponds to that central angle, so it's kind of related to the degrees. And so an arc measure of 90 degrees means that the central angle, corresponding central angle, has an angle measure of 90 degrees. And so that's how the central angle corresponds to an arc measure. Now, depending on what, how your arcs are measured, you have three categories. Okay? You have a minor arc, a major arc, and a semicircle. Okay? So it's all based on a semicircle. So let's start with that definition here first. And a semicircle is an arc on a circle whose measure is exactly equal to 180 degrees. Okay, when you name a semicircle as an arc, so this arc right here is an example of a semicircle. Okay, when you name a semicircle, you name it as an arc using 3 points. You need the two endpoints, Q and R, and then a point that it passes through along the curve. So in this case, point S. And then it has an arc symbol over the top. So this is how you would designate arc QSR. Okay. Now, that's a different arc than this lower arc. If we wanted to name this lower semicircle here, what we would need is a second or a third point here, a point somewhere on the arc. We'll call it T. So then QTR with an arc measure over it. That still represents a semicircle, but it's the different one. These are two different semicircles. Here, the QSR is this one on top. QTR is the one on the bottom. Okay, but semicircles have a measure of 180 degrees. It corresponds to that half of a circle. Okay, now, with respect to the semicircle, a minor arc and a major arc are larger or smaller than that 180. So a minor arc is an arc on a circle. Whose arc measure is less than 180 degrees. Okay, so here when you look at this example, I see that arc AB is smaller than 180 degrees. And so if we named that with an arc symbol, again, the endpoints, you'll always start and end with the endpoints of an arc. If it's a minor arc, you only use 2 points. Okay? If it's a major arc or a semicircle, you need to designate that you're passing through another point, so you need a middle point for those. And so if instead of the arc AB, if I wanted to refer to the other portion of this arc, the remaining portion here, this would be referred to as a major arc. Okay, so if it's greater than 180 degrees, you would still name it with the first and last points, A and B, but you'd have to pick a point that it passes through. So arc ADB, in this case, is your major arc. Now, when you look at these combined, right, what would the total arc measure of a circle be? Around a whole circle, from here all the way to this, would be 360 degrees, right? Okay, so when you're finding arcs, and if we just use the easy 100, if we had this measure of 100 degrees for our central angle here, what would be the corresponding major arc? What would be the measure of this portion right here? We have a central angle of 100, which means that this corresponding arc measure would also be 100 degrees, which would then mean that this corresponding arc measure out here would be the remaining 260 degrees. And so you'll use the sum of 360 to help find what the different arc measures would be. And so just really quickly see if you can answer both parts of each of these three questions here. And once again, you can enter answers as calculations for these. So if you're entering, remember the two points when you're naming the arc, and the little m in front just means measure of. So the measure of arc AB corresponds directly to that central angle, 102. ADB, the remaining major arc, would be 360 minus 102. Right? If you did the calculations on that, it would be 258. So either of those would be acceptable. Okay, for the next one, you have this semicircle, and so AEB is 180, so is ADB. They're both the same. You don't need to use any calculations for those. And then finally, the last set, you have a minor arc, AB, that's equal to 42 degrees. And then the major arc is going to be that 360 minus 42. And if, again, you calculate that, you get 318 for your measures. Any questions on working with the calculated arcs? So again, arc measure is different than arc length. You will hear both. We'll talk about arc lengths later. And so it should make sense based on what I just talked about. The total sum of the arc is 360. And that the arc addition postulate works just like segment addition and angle addition. And that is that the sum of the parts is equal to the whole is going to work for arcs as well. And so what this says that if we took the measure of arc AB and we added the measure of arc BC and then added the measure of arc AC, or I'm sorry, if we took those two, then they would together form the whole arc measure from A to B to C. Okay, and the same holds true. We talked about the alternate forms of the segment addition and angle addition, and that is if you took the whole ABC and you removed one of the parts, so if we removed arc AB from that, then we're going to be left with the other part. And so the sum of the parts equals the whole, or you can also, again, say that the whole, or the part, is equal to, I'll write it this way, the part is equal to the whole minus the other part. And so that's the relationship that you're looking at here. The same holds true for angles. All right, so I want you to see, can you find these designated measures, BDE, ABD, and AD based on what you see in the measurements given? And can you add together the corresponding parts that make up the whole measure? Once again, remember you can use calculations as you enter these. I would encourage you to do that. So if we start here, ABD, so A through B all the way to D. And you have two options for this. You could add all the parts together. So you could say 154 plus 26 plus 141. If we took that calculation, 154 plus 26 plus 141, we get our answer to be 321 in that case. But there's another way that you could have done this. And you could have also used, since there's 3 parts that you're adding, what you could have done is you could have removed, right? If you could have said that the whole thing is 360, and you could have removed these 2 parts here. We could have removed 26 and 13. So if we had taken 360 minus 26 minus 13, notice we get the same thing. Okay, so either of those sort of ways to build it or deconstruct it would give you the measures that you're looking for. All right, so if we looked at the other examples here, okay, here AD, the fact that it's just A and D without another letter in between means it's going to be the minor version of this, so it's just directly from A to D without going beyond 180 degrees. And so we're just going to add those two, 77 plus 10, which is an easy calculation. So you would get 87 for that measure. And then the final question here, from B through D to E. So pass from B through D, then all the way to E. Now, you can see that it's diameter right here. If you need to add them and confirm, it will confirm them. But you get 180 degrees, or since that's a diameter, you're dealing with a semicircle. And so that would be your measure. And once again, all of these are in degrees. I didn't label them here, but when you're calculating a measure, it's in degrees. All right, the final relationship regarding the arcs and the angles. Okay, first, a couple things. Congruent circles theorem, what that says is that 2 circles are congruent if and only if, again, meaning both it and the converse are true. They have congruent radii. Okay, so in this particular case, if AC is congruent to BD, then circle A is congruent to circle B. Okay, now, related to this is that all circles are similar to each other. Okay, so that's a related relationship when we start talking about similar figures. Okay, even though a circle's not a polygon, all circles are similar, so the proportional relationships and the ratio of parts, ratio of areas relationships, those are going to hold true for all circles as well. Okay, and then the final relationship here, the congruent central angles theorem, says that in the same or congruent circles, two arcs are congruent if and only if their central angles are. Okay, so here within this given circle right here, okay, if you have 2 central angles that are the same, then that means that their intercepted arcs here are also going to be the same. Okay, if you have 2 circles, they don't have to be the same circle, but if 2 congruent circles, same relationship holds true. Any corresponding central angles correspond to congruent, or congruent central angles correspond to congruent intercepted arcs. All right, so based on this, I want you, relationship here, see if you can answer this last question, please. So when you're looking here, you have a central angle of 26. That means that the corresponding intercepted arc is 26. Since vertical angles are equal, that means that this angle is 26, giving you arc ST being 26. And then you know that RS and QT are each, again, you can either think of a linear pair right here. So if you took 180 minus 26, that would give you an angle of 154, which would then correspond to this arc measure of 154. Same, opposite it, these congruent arcs will be, or the congruent angles will give you congruent arcs. And so if we just label what we have, RQ is 26, RS is 154, ST is 26, and QT also 154. So those would be the remaining measures here using those properties.